So hi everyone, this is Joel over here. So today I have created a new model for detecting Parkinson disease. So before explaining the ML concept, I'll just tell you what is Parkinson. Parkinson disease is a brain disorder that affects the movement when the dopamine stops segregating, or else when a person has a lack of dopamine, he used to face all these kinds of emotion, which is like masked face, or else like nervous disorders or reduced arm swing. So this is the clear picture of a person who has a Parkinson disease, which is usually common to the humans after the age 50. So I have created a ML model which is gonna detect the person whether it's healthy or else having a Parkinson or not. So the workflow of the project. So once first step, we are just collecting the data, and the data has been processed and split into training data and as well as testing data. And we are gonna use SVM classifier to classify the datas. And once the SVM classifier is been finished, the new data is been given to the trained SVM classifier, and it's gonna give the result whether it is a Parkinson or healthy. So tech stack, I have taken the dataset from the Kaggle website. So this is the web page, and yeah, this is the data over here. And this data has been given in the terms of frequencies, I mean hertz, which is a voice data based on the patient's voice. The speech is being recognized, and based on the speech, whether the person is having a Parkinson disease or not is being detected. So this is the data, and the link of the data has been given. So yeah, and Google Collab notebook, which is the notebook which I have been demonstrated. So let's go on to the Collab. So this is the Collab notebook which I did. And before starting, we have to implement the dependencies. So I have used NumPy, Pandas, and sklearn packages. And sklearn, I have used training and test splitting and standard scale SVM and metrics for accuracy score. So I have mentioned again the dataset link over in Collab also. And once you download the dataset, make sure the dataset is in the extension of .data. So you have to convert it into .csv, and then please open it in your Collab. So here you can see. So here you can see the data is being empty over here. Just click on this upload button and you can be taken to the file, and this is the parkinson.csv file. So once it's been clicked, it will ask for a alert message. Just click on OK. So yeah, your file has been imported successfully in Collab. So once the data collection has been done, so let us run simultaneously. So now you can see the input dependencies have been successfully run, and data collections too. And yeah, data head is a keyword which is used to give you the first 5 rows of your data set. And data.shape, it says that the data set has 195 rows and 24 columns over here. And this is the info of the data. And it has all the details which is being included in the data set. And this is called to find how many null values have been presented over the data set. So right now there is no columns with null values, so every columns have been properly structured and labeled, and it's filled over here. So no need to worry of null things. And data describe. So data describe is a function used to give the values of mean, standard deviation, and minimum, and this is called 25 percentage, but it is commonly known as 25 percentile, not a percentage. And yeah, all the statistical informations have been shown with the keyword called describe function. So now our motive is our data set has a column called status. So status, it has either one, okay, um not over here, status. So it has either 1 as a value or else 0 as a value. So 1 indicates the person has Parkinson and 0 indicates the person doesn't has a Parkinson. So this is being given in the Kaggle website. When you're downloading the dataset, please go through the guide page over there, get the details of the dataset, and yeah. So this data bracket status dot value counts gives you the values which is associated with the particular column. So 1 holds 147 rows and 0 holds 48, which means 147 patients have been having uh, Parkinson and 48 patients have been detected there is no Parkinson and they are healthy. So next you have to group the data. So we are just grouping the data over here, and grouping is for like grouping is to be done because here you can see all the values are being in the different ranges over here, which indicates very hard a programmer to can program a model. So grouping is a concept where you're just combining all the datas in the rows without changing the meaning. So you can so that easily it can be used by a ML model to detect our result, and it is being grouped by the column variable called status. So first column is being your status column. So first row indicates healthy person and second row indicates Parkinson person. And next thing, we are just creating a two variables which is x and y. So this step is called data pre-processing. So x is a table, I mean, X is a data set which doesn't have two columns, which is name and status. And Y is a again the same data set which has only the column of status. So we are splitting the data set into X and Y variables. And once the data is being splitted as per our workflow, we are just making training data set and testing data set. So now, once here you can see x train, x test, y train, y test has been created for variables, and train test split, which is x comma y, test size 0.2, random state is equal to 2. So what we are doing over here is we are just telling take 20% of your data as a test data and remaining 80% as a training data. So basically a training data should be containing more rows compared to test data, and random state is a variable or keyword which is used to pick the data in a particular manner. If I mention a random state equal to 2 and even you're mentioning the random state is equal to 2, so both of us will have a same kind of classifications of training and testing data. If random state is equal to 3 and I have a random state equal to 2, so our model training is been different. So this indicates like a mentor and student has to be collaborated together for preparing a model. So once the training data has been split, so you can see first data set in X shape, which is has like 194 rows and 22 columns. So in training data, we have 156 rows and 22 columns. And in test data, we have 39 rows and 22 columns. So once this splitting of data is done, so next we have data standardization. So we have to fit the data into a scalar to prepare or to make a model trained. So x train is equal to scalar dot transform brackets x train, which indicates we are fixing the x train into a particular scalar, and even x test into a particular scalar. So once it all been fixed, now it's time to train our model. So as I said, we are just using SVM model to train our thing. So before training, I'll just tell you what is SVM over here. So SVM is called a support vector machine. Basically, it has two classes. Here it has been shown as x1 and x2. Consider either one as a class A and class B. And these two classes have been splitted into an hyperplane, and this is called L1, L2, L3. This hyperplane is a clear visible of splitting of data of both the classes. So this is what we are going to do over here. Consider the blue balls as 0 and red balls as 1, which indicates blue as healthy persons and red as Parkinson disease persons. So we are going to use this technique to our model and we are going to classify the data set. So let's go to a Collab and let's train our model. Since it's a very small data set, the model has been trained properly. And yeah, once the training has been done, you have to evaluate your model to to test the accuracy. So here first, X train prediction. I mean the X training set has been find out the accuracy, which is like 0.88. It is like approximately 88%. And for testing data, we have 8.871, which is 87%. So here you can see it is both the training and testing is almost equal, which indicates there is no overfitting and underfitting in our ML project. So what is overfitting and underfitting? Overfitting is a ML keyword which is termed as when a model learns too much with more noises is called as overfitting, and underfitting is like lack of information a model learns is called underfitting. So overfitting and underfitting can be found using accuracy. And yeah, so we have created a model and we have tested our accuracy, and it's time for testing with new inputs. So I have tested with already a input, so let me erase it. Okay, so now I'll just open a data set of Parkinson, and this is the Parkinson data set. So over here I have almost 200 rows of thing. So let me pick a single row and let me choose of this. Let me copy it. Yeah, I have pasted over here. So now, over here, if you remember, we had removed uh, name and status in the training data set. So which means we have to remove a patient name and status of the patient, and the model has to predict. So here you can see one over here, the one over here. So this is a status column. So let me remove the status column. So now based on our input, our model should say the particular data set indicates the person has Parkinson. So let's run and check. So yeah, you can see it shows one. So one indicates Parkinson, which we have seen already over here. So one is Parkinson and two is healthy. So according to our input, our model has correctly predicted whether the person has a Parkinson disease or not. And I'm very happy to start my first ML project with health factor and hope it goes well. Thank you.